Hey everybody, this is Larry. This is day 12 of the Advent of Code year 2024. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, today's part 1, part 2, my solution, everything in between. Let me know in the comments. I'm really excited, kind of. I'm just too tired. It's been raining all day here in New York City, and I just did my run. So I'm just like, I don't know, really drained and tired. I have excuses every day, it seems like, but regardless, we have a minute to go, and I don't know. It's looking like it's not gonna be a great Advent of Code year. Only once in the top whatever on the leaderboards, on the global leaderboards. So hopefully, maybe we'll start something new today. Hopefully, maybe not. Hopefully, though. But yeah, about 30 seconds to go, so we will see on a Wednesday going to a Thursday. So yeah. Ooh, all right, wake up, Larry. Let's go. Let's do this. Ooh. Yeah, good luck to everybody as well, by the way. If you're watching this, you're in the future, so I don't know. But give me all your strength, or something like that. All right, 5 seconds. Focus. 4, 3, 2, 1. Go, go, go. Okay. Right. I have to remember how to get this. Okay. What am I doing? I'm too slow on this one. I should have known this one though. Strings. Nope. That's not right. Huh? What did I mess up? This should be right, but I'm really bad at this today. Oh, it's uppercase, Larry. Is it too upper? Huh. Okay, and then now, what is that area? Okay, so that's the perimeter area is gonna be equal to why am I so slow? A is R is 9 and 12. Okay, that's fine. It's P times 2. So then now I'm too slow. What am I doing? I'm not confident in myself enough. Ooh, that's wrong though. Well, why are you wrong? 18, 12. I is 4 times 8. Why is that wrong? Am I misunderstood? So why is there 4? Wait, did I misunderstand? Oh, there are 2 of them, but okay. So 4 times 8. I think I messed up. I misunderstood this problem, what they were asking for. Yikes. Too slow. I misunderstood. I thought you're supposed to aggregate them, that's why. Okay. I mean, this is actually a much easier problem, but I did the wrong one. Okay. So frustrated with myself. I'm gonna go to area, right? This should have been my type of problem too, but I'm too not smart enough for it today, I think. Basically, if this is the case, then now always excuses, Larry. Always excuses. 1519 is wrong, so I'm wrong anyway. I don't know what's going on here. R is 12 by 12 is wrong. What did I get wrong? The area, or seems like probably the area. Why would area be wrong? 1. Why would the area part be wrong? Why would the area part be wrong? That part is the easy part, Larry. What are you doing? I am just dumb today. Maybe every day, but still. Is it? No, I got the perimeter wrong. Okay, I think the perimeter is wrong. Okay, that's fine. That is actually more okay, yeah, that's why. Okay. 1930, so okay. Because I'm going out bounds. 613, okay, what am I doing? Where's the new price? Okay. Contains 8 side. What is the side? Each straight section of the I see. Huh. That is funky. I mean, maybe I see. I don't know if I see. Let's just put in the code first. Huh. How do you determine a side? I totally misread it. Stop feeling sorry for yourself in Golai. I don't know. I mean, I know how to do it, I guess. Sides is perimeter, so maybe I have a. Does that work? Not extend. What is it called? I think it's just actually in set. I think this is the syntax. Okay. So then now, I think that's the syntax actually. And this is gonna be. Then now we have to merge the sides. Okay. So then. How would we merge it if that's the case? No, that's just part one. So okay, so how would I merge it? How would I merge it? Okay, if dx is equal to it's not equal to 0, then maybe we have to do dx, right? Or maybe just dx dy, and then we combine dx dy next to each other. Does that make sense? Well, I mean, I want to sort, and then now I mean, this is just so annoying. Okay, maybe, I don't know. We're not going to make top 100, so oh well. Just misread. I don't know that I would have even if I read it correctly. This feels very ChatGPT about the part 1 anyway. Part 2 is tricky to get right. How do I want to represent it? Okay. Okay, so then now maybe for xy dx dy, this is kind of weird, right? For t and p tuple, then we want to say, okay, 0, 0. So if whatever, new x, new y, dx, dy, if dx is not equal to 0, right, that means that it's going to be plus 1 minus 1. So that means it's going up or down. So that means that we want to look to the left for denormalization. So to the left it's going to be ny minus 1 if nx, ny, dx, dy, not in p, then we just do and then we do the same thing with dy, right? Maybe. We have 1206. Okay, there you go. 55. Oh, I gave up hope, but apparently part 2 is harder than I thought. I was so wrong on part 1. I solved 3 problems today, so and still got top 100. So all right, all the doom and gloom, I still kind of made it to the top 100. Yeah, I'm kind of, honestly, I'm a little bit surprised, just because I spent a lot of time on part 1. Well, part 1, there's no chance. 2 minutes is too fast for me to finish. Well, I don't know. 2 minutes sounds about right if I, oh, let me change the screen real quick. We'll go over the problems, but I'm just looking at the leaderboard. 2 minutes, if I knew exactly what I wanted to do and I got it right, then I would have gotten it. Then 2 minutes is not that unreasonable, but how long did I actually end up taking it? I don't even know. For part 1. So part 1 I got 9 minutes. Some of it is because I spent a long time doing the wrong problem. So what was I doing wrong? Well, I guess we'll get into a second. But about 6 minutes for part 2, which is kind of happy. So if I didn't take 9 minutes, maybe if I taken say 6 minutes, so I would have maybe in a good day, maybe I would have shaved off 3 minutes. I would have been like top 20 even. I'm actually surprised not many people got part 2. That also, I don't know if it felt, I guess maybe ChatGPT doesn't have this idea of sides, I guess, right? Maybe that's kind of, I don't know. If I have to guess, I guess that must be it. Yeah, I don't know. But, you know, finishing is quite happy. Top 100 is, yeah, I mean, because part 1 is way ChatGPT-able, right? Like, I think that is relatively standard. I say everything is standard, but it's one of those things that, my apologies, I don't even try to minimize it. But like, there's this saying in math sometimes where like everything you know is trivial and everything that you don't is impossible, you know. And sometimes I tend to, that happens to me sometimes where I'm like, oh, it's standard. But I feel like, I mean, I could quote theories and we'll go over the problems, so then we'll do that for sure. But I just mean like, because all the ideas are things that are out there and knowable. Like it didn't surprise me that it was ChatGPT-able. But I mean, I did also do the wrong problem. That's a shocking result for me, actually. Honestly, this is like the happiest surprise this advent of code so far. Is that I mean, I took so long on part 1 and I still got part 2, so I'm really happy about that. Let's go over the problem real quick. So, oh yeah, I'll also go over very briefly what I did, or how I read incorrectly. I mean, it's very hard, right? Because there's so many things to read. The same type can plants of the same type, right? And I actually thought that I misread this part, I suppose. But no, I mean, no, I think I read this part correctly. But then I think like they kind of talked about X here. But then I kind of, I don't know. I think I guess I skipped this part. It's the TLDR, right? Do I have to write? Oh no, okay, let me put it back up for a sec. I skipped this part because I read this correctly about them, but then I thought that you're supposed to sum over the area and the perimeter for each plant type. I guess this is the problem. And because I did that, and I didn't really do it in a way that was, yeah, and I had to rewrite it, which, I mean, it is what it is. Right, because I just misunderstood the problem. Because what I did is that instead of 1 times 4, well, I guess for this one it's the same, so it didn't matter. But for here, what I noticed was that, and it took me time to debug as well because I didn't know why I was wrong. But it's that, you know, for example, there's 2 i's. This is 4 times 8 and 14 times 22. But I was doing like 18 times 30, right? The sum of the area and the sum of the perimeter, and that's why I was getting the wrong answer. And it took me a while to be like, oh no, Larry, you're solving the wrong problem. And here's back the code, and this is the wrong problem solution, but this is the right problem, or right something, I suppose. Yeah. And I do have this thing called infinite grid, and the code here is actually not that interesting. It just kind of handles wrapping for me, like going off the grid if I have to, which actually was helpful for this problem, but also not super necessary. It's just kind of me lazy thing. But it also means that I could have taken this out, but then I just kind of, old habits die hard, I suppose, right? Because yeah. I guess I'll take it out now, just for whatever. Whatever. I don't know. Maybe put it back in. But because you can go outside the bound, I actually have to take it out. But okay. So what does this do, right? So let me put up a. Hang on a second. I'm gonna put up a drawing to the board because I feel like this is a. You know, this is a very obviously a visual problem, so I'm gonna bring up something for visuals. But yeah, but the idea here is, and it is actually I don't know if it's easier or harder with, I mean, I had to do it twice anyway, so I don't know which way is easier or harder. I just, you know, did this way. But the idea is that, okay, so I'm not going to go over the area part. The area part is just a depth first search or breadth first search. You know, you just a flood fill algorithm. I know that I hand waved that a little bit, but yeah, well, maybe we'll go over it. But the flood fill algorithm is the idea behind the area part. That is it, right? And the idea behind flood fill is that, let's say you have a grid or an area chunk, right? You kind of just look at each neighbor. I don't know. I'm drawing random things, so like don't you know, forgive me for whatever. But the flood fill, which via breadth first search, is that like you start at one. Oh, I thought I changed the color. Why didn't it change? That's some weird thing. Is that, okay, you start at one cell, you go up, down, left, right, and you visit another one, and then you just kind of keep on going to neighborhoods or neighbors, right? And then at the end, you just count up how many things you have. That's pretty much it. And the reason why you need this, of course, is that you do need the area for different plant types. Or for the same plant types, but in different areas. So let's say if these are all in one type, and then you have another one that's identical, but if they don't connect, you have to count them separately. So that this is where flood fill could be, and without playing around with our specific inputs, which maybe there's some properties that you can exploit, but you don't need to because this is a general algorithm. So flood fill, you just kind of, okay, well, we haven't done this one, so it doesn't even matter what plant it is. I almost say color because color is a thing that comes up more in a lot of these problems, or the idea of it anyway. And then you just kind of flood fill, right? So that's for the area part. Hopefully I don't have to explain it too deeply. It is actually one of the more fundamental concepts, or at least like one of the more introductory, like a thing that you'll find in an intro to algorithms course. So I'm not going to go over I mean, we'll go over the code, but in terms of algorithm, I'm not going to go over it that detailed. But the other thing is that, and that's the part that I kind of wrote it 2 ways, is that to try to find perimeter, right? And and the first way that I did it is knowing that if you put like a ray as an array of sunshine or something like this, almost like ray as in ray tracing, then and given that this is a grid, anytime you see a cell going inside and outside the boundary, well, you're going to have +1, right? So there's +2 on this one. So as a result, that's how I initially got it, is that you can kind of think of it as that I scan almost like a sweep line kind of, but not really. I just scan from left to right, and anytime I see differences, right? So for this one, it is obvious because there's only one cell, but it's a little bit different for this one, right? Because then now in here, we only have to look at adjacent elements. So then we only have one in and one out right here, right? Maybe I should have changed the colors, but let's see. Right, one in and one out. So then now you know that 2 perimeters happen. So that's one way to kind of go about it. It turns out that I guess you can actually, it doesn't really matter in the sense that I think the hard part for this also is the attribution of perimeter, right? Meaning that again, if you have 2 areas with the same plant but different garden or different whatever they call it for this problem, then you have to be careful that like. If you do a array here, well, this only counts for these 2 and not this one. But then if you do it here, they'll actually 2 ins and 2 outs, so 4 adds 4 to the perimeter. So that's really the idea. And without loss of generality, you can kind of rotate the graph mentally in your head to kind of just go from top to bottom or bottoms to top. You know, either way is fine. So I'm gonna go over the code, but that's basically what I do, right? So for each cell inside XY, this is a flood fill, and we kind of did connected components the other day, right? Or am I mixing problems from different contests? I don't know, but either way, yeah. So here we have, and I do have I just call it D4, meaning up, down, left, right. I have pre-typed because it does come up enough times, I suppose. But yeah, and then I go dx dy is you go or nx ny, which I just in my head think of new x new y as you go to x plus dx y plus dy, and this is to kind of get the recursion going. The done is allowing us to just to make sure that we don't visit the same cell more than once. This is a regular depth first search flood fill, so that you know you have a. If you can imagine like a cycle, well, we don't kind of double count things. So we only go there. And this is a recursive thing where we turn a tuple of the perimeter given the perimeter contribution by that cell, and then the area contribution by that cell. The area part is a little bit easier. We just kind of sum up the area. We start with 1 because if you had a cell, we already, you know, just start at 1. And then the perimeter contribution is just, well, recursively, but also going up, down, left, right. If the what I call the cell color still, but the plant is different, then you do +1. But keeping in mind that I do use I do take advantage of my setup of to infinity grid, and let me actually put up my infinity. Ooh, whoops, one run. Actually, maybe that's fine. Let me put up my infinity grid code just so that it's not that interesting, honestly. But I just want to see. So this is my to infinity grid code, which is just basically given the input. I literally just have 2 collections or 2-dimensional collection of default dict, so that allows me to index by anything. I don't know if this is that helpful, honestly, but I don't know. It's just I'm playing around with this here, so this is a new to this year kind of thing. But yeah, but what this means is that it allows me to go outside, because everything that's out of bounds is by default an empty space. So that's why I kind of have this here, or I don't have this here to check, because if it goes out of bounds, then it's an empty space, and by default this would not be equal, and I get a +1 on the perimeter. And actually, if you kind of watch the video back, I actually it took me a second try to kind of second run before I'm like, oh, I didn't take account out of bounds stuff to kind of get this right. And then yeah, at the end of the day, we just kind of sum it up. This is regular flood fill things to make sure that we look at the entire graph, or the entire grid. Sorry, it's a graph, that's a grid. But anyway, yeah, we got the perimeter and area, and then we just kind of do the formula they tell you, and that's pretty much it for part 1. Where's the complexity here, right? There's a lot. It's a whole mess of things, but really we look at every cell once, right? Because we keep track to make sure that every cell is only looked at once with this done variable. So as a result, this is going to be linear time and linear space, maybe ish. No, I think that's right, because I'm just thinking about the core stack. But at worst, you have R times C core stack, and that's linear. And when I say linear, just to be clear, because I think people can get confused with linear because they use O of n notation, and then they assume linear always means O of n, which is true, but only when n is the size of the input, right? In this case, n is equal to r times c, so O of n is equal to O of r times c, and that's linear in the size of the input, both in time and space. Sometimes and I say that to differentiate because sometimes people get confused when you have a square grid. If you have a square grid, let's say like 10 by 10 grid, your n is, and then they use n as a side of that square. So then you have n is equal to 10, so, and you have some n square algorithm, but it's n square, it's still linear because you have n square input, just to be clear. All right. I know maybe I'm going a little bit fast, but we're still on part 1, so but I just want to clarify certain things because these are things that, at least in my experience, and I have thousands of videos now at this point, people get confused a little bit. So if that's not you, that's okay. Well, maybe it's a nice reminder. So for part 2, clearly this is very hard. I thought that it wasn't that bad, per se, in theory, or like I had ideas. I honestly did have the idea in my head, like as soon as I finished understanding it, like what a side is, right? But I was like, this is so annoying to implement. But it turns out it wasn't that bad, but it did get me top 100. So yay, go Larry! I don't know. I'm actually maybe this seems too self-congratulatory, but I mean, I really and I talk a lot about my mental clock and stuff like this, but this was actually very unexpected. So I'm pretty happy, and especially after this year of advent of code, it just feels like, I don't know, I didn't know it would happen. But anyway, that aside, you could kind of notice that most of the code is exactly the same. We still use this idea of flood fill. So here, the only thing that I changed is that I used a set. I don't know that this is the best representation, but I just knew that if I dump things in a set, I'll figure it out later, kind of thing, honestly. And the idea that I'm trying to do here, though, the change, because it doesn't look like much, which is true, is that I'm going to bring back this graph. Okay. So what is a side, right? So the way that I thought about it is a way to try to figure out how to normalized by a side. And I took the wrong thing, hang on. And what do I mean by that, right? What I mean by that is that I gotta stop doing random things. I need like random silly grids around or something, right? So maybe someone like this, right? And the idea of a side is that the way that I thought about it, and I don't know, I just drew this randomly, is that a side is kind of, well, what it sounds like, right? Hopefully by if you're watching this and you already read the problem, you understand what they meant, what Eric meant, right? It's just that it's one contiguous thing that let me change the color real quick. One contiguous thing that is one fence, right? So if we were to kind of add a thing here, how come I didn't draw? If we were to add a thing here, and maybe even extend it, these are two different sides, right? Why is my drawings? I don't know if I'm clicking on the right thing or not, but apparently not. Oops. But the two red lines are two different sides, right? So that kind of get there. So then the idea that I had was that, okay, well, there are only two. Well, the first idea that I had was that there's only two distinct, there's just vertical sides and then horizontal sides, right? So that's one. And then the second thing is me trying to what I call normalize it. And by that, I mean like group them in a way such that, well, you only count them once, right? So the idea here is actually kind of, I don't know if this is like crazy, because like I said, I didn't actually think this was that, like I underestimated the difficulty. I mean, I still did it, but just by the results, I clearly underestimated. What am I, George Bush? I underestimated the difficulty might be. So I'm going to try to go slowly and explain this a little bit. But honestly, to me, like it was like it came almost immediately. And the idea is that, okay, let's just look at two sides at a time, right? So this one, and maybe I'll change the color. This one, and then the idea here is that let's say without loss of generality, let's go on horizontal first, right? Well, then here, that means that in one side, we want to count, let me change the colors again, because we want to count this one, but not this one, right? So, and the way to do that is that if we're able to kind of have a consistent ordering, then we're able to normalize it by that way. And what I mean by that is just that here, if we're going from left to right, then now we know that to the left of this line, there's nothing, but to the left of this line, there is something, so then we don't count it. That's really it. That's I mean, it's easier to say than to implement in all these things, but that's really it, right? And to give you a longer example, because this is 2 cells and kind of crappy, and you can kind of feel like in an almost induction kind of way, like you count this one, colors are hard. You count this one, right? But you don't count this one because to the left of it, we have something. We don't count this one because to the left of it, we have something. And then that's it. You could do the similar idea with up and down, and that's pretty much it. And keeping in mind that for each, there is an additional variant that I don't think I took advantage of it directly, but you could have if you, is that for this particular line, yellow is binding. There's only one way, right? Meaning that because if you're in, the yellow is terrible actually. Hot pink, there you go. For this line, you only look, it can only be down, right? And what I mean by that is that it cannot be like there's no way to kind of wrap around and then have a thing go up just by, I don't know if there's like a mathematical principle or whatever, but it's just like that's how the physical thing is constrained, right? And so with that idea in mind, we can go over the code, and that's basically what I did. Is that so I had this idea, as I said, like almost immediately. I just didn't know how to implement it, and I don't know that I ever implemented this idea, frankly, just to be clear. But I was how I did it is just try to figure out like how to represent different components of one line with one thing. But the way that and you have to put a few things together. One is the ordering, right? Because if you kind of go from right to left because you just didn't think about it, or you assume that both direction works, then you have to look at the right thing previous, right? I mean, it still works, the idea still works, but you have to look at the consistent ordering, right? And then the second part is just try to figure out a way that dedupes. So that's basically the idea. And the way that I did it is with a set. So for perimeter, I have a set. So for the flood fill portion, I just same thing, except for instead of adding incrementing by 1 on the perimeter, I add 4 things: x, y, dx, dy. And the xy part, I mean, I hope that makes sense. It's just a cell, right? And then the dx, dy will allow me to determine whether, okay, so we're given a cell, we're given a perimeter, and it just tells me like which direction it is, right? Is it an upper perimeter, a lower perimeter, and so forth? And it turns out that there's no, as I said, there's no way to kind of like, well, actually, I guess there is, now that I think about it, but luckily, it doesn't matter. And the way that I was, the edge case that may be a little bit tricky if you're a little bit sloppy, actually, is something like this. Let me, I suppose, is something like, if you have something like this, well, so maybe you have like something like this, and then now you connect them, right, in some way. This looks kind of confusing, actually. So let me throw them in by color, right? So let's say you have these cells. So if you're not careful, you're not supposed to merge this line with this line, right? For obvious reasons, but I'm just saying like these are edge cases that you have to kind of consider and make sure you don't. And that's why you have to be careful, right? Okay, so yeah, so that's why I said upper and lower, but on the same, it should not like merge, right? Because if you have two things like that, then they just become one block, right? And that's the definition. And also by definition, they cannot be not alike, right? So I have the set. So that's kind of the easy part in the whole grand scheme of things, right? Because it gives us the an actual way to reconstruct the perimeter if we like. And then the part that dedupes is kind of in this magic here is that keeping in mind that actually, I made a mistake. Oh, I actually had some code that I made, so I got a little bit lucky actually. I lied and I got a little bit lucky. I mean, it is a property of set in Python, but I always like to write it explicitly because these things are kind of sometimes like it's easy to assume, right? And what I mean by that is just like that we should sort by we should sort these things, so that the reason why we want to sort is because then it gives us this structure of this ordering going from left to right and also from top to bottom, right? From small x, well, small x to large x, from small y to large y. But I guess it actually doesn't matter now that I think about it, the way that I construct this, because we do it on a second pass. But let's say if you were to construct it in one pass, then the order matters that much. So I think that's why actually I don't actually need this now that I think about it a little bit more. Sorry, I'm recording this live, so forgive me if I'm like a little bit imprecise in some of the stuff. But basically that's it, right? So if dx is not 0, that means that it is going to be an up or down thing. Then if you kind of visualize it, right? Let's just say up for picking a direction, doesn't really matter. If it's up, then we want to make sure that to the left of it, a thing doesn't exist. And that's pretty much it. And that's what I have here, right? I have nx, ny, dx, dy. So we kept the dx, dy, and even nx, we just move to the left. And if it's not, then if this is a new thing, because it's not there, then that means that this is a new side. And that's pretty much the old idea that it is. And without loss of generality and for symmetry, dy, we basically do the same thing. And that's it. And then we do the cost formula, we point out the cost, and bam, we're Gucci. What is the complexity of this, right? So this, you may think, well, look, Larry, there are two for loops here. There's another crazy for loop with p, where p could be r times c, right? So isn't this like quadratic? The answer is actually, surprisingly, maybe. No, this is also linear time, linear space, right? The linear space comes from p set. Well, okay. Maybe I want to add a little caveat here in that, no, I mean, the way that I implement this, actually, I'm lying to you. And the reason is because of this p set construction. You could actually rewrite this as like small going to larger, and actually that will improve performance. Another way that I would have maybe written it is with a global variable. But the reason why this is actually not linear, and I just lied, is because this function is linear by itself, and as a result, that actually changes it. But you can actually rewrite this in a way such that that's not true. Maybe we can do it, but it makes the code actually slightly uglier. But which maybe is fine. I don't know. Like, yeah, I mean, I think it's fine, maybe, right? So here, what I mean is that you just don't return p. You just kind of, you just kind of do this. And then now you have p is equal to set, and we're supposed to go to here. And then now we have non-local p, and I think that should work. Let me confirm that that works first. Oh no, because I had to change some stuff like here, right? Okay, I don't know if that's right. I hope that's right. Let me double check before I lie more. No, that's wrong. Oh wait. How did that go wrong? How did it go wrong? Maybe I am lying to you then. Huh. Oh no, I was looking at part 1's answer. Okay, I keep making that mistake. I was doing, so okay, so I didn't lie to you. Now it's right. But yeah, but just by doing this, now it is actually linear time, linear space. I didn't really address the part. Sorry, I had, as I say, this is recording live, so my apologies. But yeah, now as a result, if you look at just p, every cell can be in p at most once, right? Because it is kind of controlled, if you will, by done, right? Dominated by done, or even limited by done. So p can only be all of n elements, and as a result, this in the for loop, if you amortize or if you sum the amortization of all the cells, it's just going to execute once per cell. So as a result, even though there's this crazy looking for loops, this is actually linear time and linear space. And just a quick reminder, linear time, linear space in this case means all of r times c. And n is equal to r times c, if you want to put it that way. And that's it. That's all I have for this one. That's pretty much the idea. Hope I covered everything. Yeah. I mean, I think I think the idea is actually very cute and elegant. At least from a nerdy math perspective. But yeah. And in theory, it shouldn't take. I mean, as you see it didn't take that long to write, which is why like during the South, I actually I thought I had no chance, so it was very pleasantly surprised. I actually went a little bit slow now that honestly, because I almost, you could say, gave up a little bit because I thought I had no chance, and then maybe I could have gone up a little bit more, but I don't, I'm not gonna complain about it. All right, it's not today. Maybe later. I'm gonna just bring the thing back up so that we can say and yeah, these are my times. Second time on the leaderboard, hooray. Maybe that's, I mean, progress is nice. But that is all I have for today. Thanks for watching. Thanks for the support. Yeah, hope to see you out tomorrow. Stay good, stay healthy, to good mental health. Yeah, I'll see y'all later and take care. Bye bye.